Okay, so today we'll look at a connection between area and the antiderivative. Um, so if we want to find the area here, we can do it geometrically. Because it's a geometric shape. If it were some function like a parabola, we don't have a formula for the area of a parabola unless we use calculus. So if we find the area geometrically, we have 3 by 4, and we just use 1/2 base times height. But we can also use calculus. If we look at this as being a function with a y-intercept of 0, rise 4, run 3, rise 4, run 3, we have that function, and we're going to integrate it. For now, let's leave off the plus c and just see what we're getting here. 4 divided by 2 is 2, so we have 2/3 x squared. If we just evaluate at x equals 3, since we're going over to 3, we would have 2/3 3 squared, and that's going to be 6. So there is a lot more development in jumping from geometry to calculus and the antiderivative, but this is just an introductory shortcut to maybe see a little connection between the antiderivative and geometry. It looks like we can just do the antiderivative and then evaluate it at the endpoint, and we'll get the right area. Let's try some more. Alright, if we have in the previous lesson we had to approximate the area, but today we're going to find the exact area. So we have the antiderivative of x squared, that equals x cubed over 3. When x equals 2, we have 2 cubed over 3, or 8/3. So if we follow that rule where we just do the antiderivative and substitute the endpoint, we'll get 8/3. This is the exact area of that region. And we just have to have one modification to that, one refinement to that rule, and then it will be we'll be able to use it on any interval. So let's think about this region. So to find that area, now it's different because we're not starting at 0. So if we did the antiderivative, we have x cubed over 3. But now what we're going to do is, if you substitute a 2 in there, we get 2 cubed over 3, 8/3. But that's the whole region. And we don't want this region. If we just find the area that we don't want at x equals 1, now we'll have we can just subtract the region that we don't want. And so now we'll know that the shaded region is 7/3. So the notation for all of this, instead of doing this and then different parts, we can just write it like this. And this is called the definite integral. And we're using the fundamental theorem of calculus. The fundamental theorem of calculus allows us to use an integral to find that area. And the notation is like this. We're going to go from 1 to 2. Okay, and then that's going to be x cubed over 3. Now we put the 1 to 2 over there. And the fundamental theorem is substituting the 2, then substituting the 1, and we'll have 8 minus 1 is 7/3. This is called a definite integral. What we had used before were called indefinite integrals because they didn't have limits. These are called the limits of the integral. And if we're going to find an area, we just use the endpoints of the interval as the limits of the integral. Here's a definite integral. We didn't represent it graphically, but it would be the area under this curve from -2 to 0. So we're going to do the antiderivative and then evaluate it from -2 to 0. So we substitute the 0 first, then we substitute the -2, 0 minus 16/4, and we get 0 minus 4 is -4. If we visualize this, we have x cubed going like this. Between 0 and -2, we would say that we have found that area. So we wouldn't say the area is -4. The integral is -4. The area is the absolute value. We'd say the area is just 4. All right. 0 to 2, -2x squared dx. Pause the video and try that one. Okay, we can put a constant factor out in front. You don't have to do that. You still get the same answer. And we're going to do the antiderivative, so that's x cubed over 3 from 0 to 2. 2 cubed over 3 minus 0 over 3. And that'll be 8 over 3. So we get -16 over 3. So here we can just do the antiderivative of each term. There's a 1 there, so we're going to add 1 and divide. This would have an x to the 0, so if we added 1 to x to the 0, now we'll have a 1 over 1 the 3 stays there. So we did the antiderivative, and now we substitute a 3 and then substitute a 1. And substitute a 1. You substitute the 3 and then you subtract when you substitute the 1. So we subtract, put in a 1. And here we get negative 9 plus 9, negative 9 over 2 plus, that's 9 over 2. So about 18 over 2. This will be plus a half and minus 3, which could be 6 over 2. So now we have 9, 10, minus 6, 4 over 2, or 2. Pause the video and try that one. We do the antiderivative of that. 2x, that's a 1 plus 1 is 2, divide by 2, x to the 0, so we're going to get a 5x over 1, and we integrate from 2 to 3. So substitute the 3. And then substitute the 2. Nine minus 15, 4, so we get a minus 4, and that's a 10, would be a plus 10. And we end up with 0. We're going to have negative 19 and positive 19, so the integral is 0. All right, let's try it with trigonometry. Cosine is the derivative of which function? It's the derivative of sine, and the derivative of sine is cosine, so you want to make sure you can check. If you go backwards, you get what you started with. We're going to go from 0 to 3 pi over 2, so that's sine of 3 pi over 2 minus sine of 0. So 3 pi over 2 is there. Sine is the y value. We're going to get negative 1. Sine of 0 is 0, so we get negative 1. All right. Pause the video and try that one. Sine is the derivative of which function? Well, if we think of the derivative of cosine is negative sine. If we did the derivative of that, so this must be the derivative of negative cosine. And if you get mixed up in that type of reasoning, you can just say, well, here's what I think it is. Let's see what the derivative of this is. The derivative of cosine is negative sine, but then do a negative sign. It'll take you back to sine. We can check to see that that's the correct antiderivative. And then we evaluate it from negative pi over 2 to pi. And we have negative cosine pi minus negative cosine negative pi over 2. Alright, pi is here. Cosine of pi is negative 1. Pi over 2, negative pi over 2 is there. Cosine is 0, so that's 0. and we just get 1. All right, last concept, average value of a function. The average value of the function is this formula, and this is from the mean value theorem for integrals. We're just going to focus for this lesson on the average value. We won't look at the mean value theorem. But you can see average and mean here. We won't quote the mean value theorem, but you can see that it's coming from that. All right. Find the average value of x plus 3 on 1 to 4. So this is a and b, and we're going to go 1 over b minus a from a to b of the function. So we do the antiderivative, add 1 and divide. That'll be a 3x from 1 to 4. And this is 1 over 3, 4 minus 1. And then we have 1/3. Substitute the 4. We get 4 squared over 2, 3 times 4, minus, now substitute the 1, 1 over 2, 3 times 1, 16 over 2 is 8, plus 12, minus 1/2 minus 3. We end up with 11 over 2, and what does that look like if we have this function? So we have a y-intercept of 3 there, over 3, up 3, because the slope is 1. So we have that graph on 1 to 4. So what it's saying is, if we looked at between here and here, what's the average value of the function? If we were looking at the area of this, is there, or what y value would divide this top part in half so that we would have a rectangle with the same area as the trapezoid? And if we go up to 5.5, 1, 2, 3, 4, 5.5, at 11 over 2, that's 5.5. What it's showing is that the area of this rectangle is equal to the area of the trapezoid. And this is called the average value of the function. All right. Pause the video and try that one. So the average value is going to be b minus a, 1 over b minus a, and then the integral from a to b. of x cubed minus x so this is negative 1 plus 2, and that's just going to be 1. Antiderivative of this is x to the 4th over 4 minus x squared over 2, and we go from negative 2 to negative 1. So let's put in a negative 1. And then put in a negative 2. So we have 1/4 minus 1/2. That's 16 over 4. We'll leave it like that. Positive 16 over 4, so that'll be a minus 16 over 4. And this is going to be 4 over 2. 4 over 2, so there'll be a plus 8 over 4. And then let's just call that 2 over 4. That will allow us to write it as negative 9 over 4. And that's the average value of the function on that interval. And we'll stop there.